So I'm back at the location, doing some test passes with the DR10M, putting in a little work. You can see the tires all prepped up over there in the bag. These tires, I'm definitely not running. These SSDs are a bit heavy. I just use it to transport to the track, so I don't have to worry about getting prep all over the place. But I'm running I changed out to the Morbo front shock tower, Morbo Servo relocator, Morbo single wheel wheelie bar, and the upgrade you can't see is the ceramic bearings. You can see those really long wires from the motor to the ESC. Kind of lazy about trimming those down. To get this wheelie bar to fit, I had to trim with a Dremel, I trimmed those wheelie bar mounts just a little bit just to get the wheelie bar to fit around it. And that worked out really well. You can see that aluminum foil wrapped around my tires. That's to keep the prep on the tire, so I can still use those tire bands until I get a portable heat gun. But I'm in this first two runs in the video, I ran the 6300 Gens Ace batteries. They do decent at low timing, so I'm only running 30 degrees of timing. I trimmed out that little front brace there to get the battery to go and move all the way forward. So weight bias seems pretty nice with this setup. I don't have the scale, so I can weigh it and show the actual bias. To get this servo to fit that I pulled out of my TF2, used some brass standoffs there to get that to offset a little bit and not be hitting up against that front shock tower. The SMC batteries don't go past the carbon fiber where the two screws are, so trimming that piece in the plastic didn't really make a difference for the SMC batteries, but it will for a future battery setup, such as the 9000 Gens Ace drag battery. There's a few of the guys running some RCs out there. He had about 15 RCs in the back of his pickup. This infraction here was doing about 100 miles an hour. He measured it on his GNS. Said he didn't want to stretch it out much more than that. On this first test pass, I'm running a set of black drag race concepts, with drag race concept tires at 40 durometer. Of course, they're prepped with live action and get stuck. It left decently well, but the servo arm shifted. I didn't know it happened at the time until I drove it back down the track, and the car just wanted to keep driving to the left. Driving to the left. But I brought it back, recentered the servo, tightened it down pretty well, and didn't have any more problems with that for the rest of the day. This pass was a 2.2 at 63 miles an hour, decent G's at 2.83 G's. And again, like I said, I'm only running about 30 degrees of timing, so my RPMs didn't get up to the 50,000, 49,000 range where they normally are. Next run, use this set of chrome drag race concepts that I have, same tires, 40 durometer, just a different finish. Similar results, ran a little bit slower. The car was going straight this time for the most part. Ran 2.3 at 62 miles an hour. You see as I drive back down, it was pretty much tracking pretty straight. And you see the data logs. It's a little peak in RPM, probably when the prep came off after I drove over into the section where I hadn't blown it off. And you can see these guys here starting to accumulate, standing around waiting for us to get out the way. This person thought it was a good idea to drive through where I was set my car up and ran my car. Almost ran over a GoPro. It's interesting, a bunch of fast cars, a Challenger, Camaros, Supras, and stuff like that, but you see this little car run through. And on test pass 3, ran the split 6 beadlocks, 30 durometer, no foam, and the left tire just blew out the beadlock and caused the car to flip. No damage to the car itself. That Morbo wheelie bar is holding up really well. Taking these crashes with no problem. No GNS data because it didn't go barely half track. And of course, in short data log, you can see a few more cars starting to accumulate. So this was my fourth and final pass. This time I'm running the split 6 beadlocks with the drag race concept 40 durometer tires. And of course, they're prepped again with live action and watermelon and get stuck prep. It kept wanting to drive to the right a little bit over into the dirty section. And then you can see it get airborne because it smacked my GoPro at the end of the track. Still no damage to the car itself, just the body. Took a big smack, got some cracks in it. Ran a 225 at 63 miles an hour. And you can see, of course, the speed slowed down at the very top.
I hit the GoPro.
But in data log, you can see the RPMs peaked while it was in the air before I can get my finger off the trigger. It's 68,000 RPM. Finally, I went ahead and did a few top speed runs just to see the benefit of the bearings, the ceramic bearings that I put in previously. The car was doing about 83 miles an hour top speed out here. You can see the car is literally tracking straight under power. And the top speed at this point was 86 miles an hour, so it picked up 3 miles an hour, and that has to be due to the ceramic bearings. And the peak RPM on this top speed run was 55,000 RPM. So this was the end of my running. These guys are still showing up, waiting for us to get out the way. In a moment, you'll see the damage that was done by the GoPro. So you can see some paint chipped off right there on the front. I lined my bodies with shoe goo and drywall tape to keep the body together when the plastic cracks, so you pretty much don't trash your body and you can still keep running it. So I reinforce it pretty heavily on the front end to also provide some bracing capabilities to keep that front from dragging on the ground. Line the sides with it and the back, especially along where this the spoiler mounts. Even with the cracks to the body there, you can see it's still holding together. I'm still running the body. It's a little bit of a flex there, but that wasn't enough to drag the ground when I was doing those high-speed runs. Thank you for watching. Like and subscribe. More content coming soon.